Okay, this is another example of what we have referred to as nature's rules and biological loopholes. This is a study that looked at years following wildfires of various severity and non-burned areas in hardwood forests of the US to look at bird abundance and species diversity, and finds interesting counterintuitive results that actually breeding bird abundance and species diversity was greatest in high severity wildfire patches. Obviously very region specific study, so generality of such a finding has to be always verified. Using fires for managing forests has always been part of human history. Wasn't always clear whether it was also done for increasing bird diversity and so on. And this compares contrasts against, for example, the silvocultural approaches where various managements of canopies and spacing of the trees, etc., is done to manage forests. So let's just read the abstract and then we'll read a few conclusion points as well, looking at some data along the way. In 2016, mixed severity wildfires in the southern Appalachians created a gradient of forest structures not typical following prescribed burns, providing a unique opportunity to study temporally dynamic conditions and breeding bird response. We measured forest structure and breeding bird communities across the fire severity gradient in 3 burned and 3 unburned watersheds for 5 years. So year 1 to 5 we categorized plots as non-burned, unburned NB, low, moderate and high severity using composite fire severity index. Tree mortality increased with fire severity category or FSC, and over time by year 5 7% of trees in non-burned, 11% in low, 38% in medium and 71% in high severity had died. Shrub recovery was rapid, most pronounced in H, exceeding other forest fire severity categories 70% versus 21% to 44% by year 5. Okay, so this turns out to be the main story, that shrub recovery was the most pronounced in high severity fire region compared to other regions of the forest. Total bird abundance, species richness and diversity increased over time in H by Y3 and M by Y4. By Y5 these metrics were highest in H and twice as high in H as in non-burned or unburned areas. Low severity wildfires had no detectable effects on birds. Okay. Abundance of 7 species was greatest in higher severity FSCs. 11 species did not differ among FSC, although aven birds indicated a trend of lower abundance in H. So some uncertainty there. More data and more sites are needed. No species was limited to unburned L or M, whereas disturbance-dependent indigo bunting, chestnut-sided warbler, and eastern towhee were primarily associated with H. Increased richness and diversity were associated with heavy tree mortality and subsequent shrub recovery in H, accompanied by an influx of disturbance-dependent species and positive or neutral responses by most other species. So you get diversity and species structure increasing by birds which are evolved to respond to disturbances, and that's how the observed increases happened. Results highlight the interrelated roles of fire severity and time in driving forest structure and breeding bird response. Breeding birds responded to high severity burns similarly to silvicultural treatments, silvicultural again being non-fire kind of forest management, with heavy canopy reduction documented in other studies offering possible alternatives when managing for breeding bird diversity in hardwood forests. So we looked at the impact of logging before and how that increased mammals and bird diversity, herbivores and insect feeding birds and so on. So this adds more evidence to this complicated response that are not intuitive in terms of perturbations, human-made or natural, wildfires, and species responses. Okay, here is the map looking at the Macon County, North Carolina. It's the Nantahala National Forest, and 2016 wildfires happened in these regions. So you can see here Tellico fire with categories of high, low, medium, and unburned. And here Tellico Creek and Chestnut Cove areas were unburned. And in the Camp Branch fire, again you had non-burned areas and various fire severity categories. This is the map, study area map, including 3 burned and 3 unburned watersheds with breeding bird point counting locations by fire severity category: unburned, low, moderate, and high severity, following the 2016 wildfires in the Nantahala National Forest of the Macon County, North Carolina. So just some data. Just look at the mean plus standard errors of dead trees in percentages of the baseline. So you are looking here at the no burn area, year 1 to 5, moderate severity and low severity burns, and you can see that from low to medium to high, the dead tree percentage goes up, and dead trees compared to in basal areas are lower. So you can see the tremendous difference in the scales. So mean plus minus standard deviation of dead trees in the basal area was much lower. So this is related to fire in that sense. And shrub recovery by year 5 is the highest in the high severity fire case. And similarly for leaf litter, didn't change much in the unburned, recovered in both low and moderate severity burns, but you can see that here the high severity burn has less leaf litter recovery because it's now dominated by shrublands. And canopy cover again didn't change much over these categories, but changed dropped and recovered over the high severity burn. And snags, which are basically standing dead trees or dead or dying trees, I suspect. So no burn, low, moderate, and high. So you expect high severity fire to create more of these, and that's consistent. But when you look at mean of total number of birds per 10 hectares, so we are here looking at species richness, species diversity, 1 to 5 years post wildfire in 4 severity categories following the 2016 wildfires. So these are the species richness. This is the total numbers by year 5. Total number of birds per 10 hectares is the highest in a high severity burn. Species richness is the highest as well, and so is the species diversity H prime. There is a definition for this which you can look up in the paper. I'm just trying to make the point again that biology has very interesting ways of finding loopholes in what we think of as nature's rules, where we assume that fire is bad, wild or prescribed fires. And of course there is the whole argument about whether fires are getting worse because of human management itself and climate change, warming, vapor pressure deficits, droughts, etc. But keeping all that aside, just focusing here again at tree nesters, cavity nesters, shrub nesters, and ground nesters, you can see that these numbers are not as obvious as we saw before. Whereas cavity nesters, again by year 5, high severity shows some increase. Shrub nesters have increased again, and ground nesters. So these are number of birds per 10 hectares in 4 nesting guilds. Guilds are kind of ecosystems that coexist. And secondary, so this building primary and secondary cavity nesters, shrub, ground, and tree nesters, and so on. So again, just very interesting results. Conclusions: high severity burn patches with there is more data in the paper that I'm not going to go into. High severity burn patches with substantial tree mortality and a resulting increase in shrub cover were a key driver in promoting greater breeding species richness, total bird abundance, and abundance of disturbance-dependent species with positive or neutral effects for most other species. So if you just focus on tree cover, obviously you may end up with a different conclusion, carbon loss, etc. But if you look at bird species and bird diversities, then you get different conclusions. In contrast, low severity wildfire patches with negligible tree mortality did not increase abundance of any species relative to unburned forest. Moderate severity burns also resulted in increased bird species richness and total bird abundance, but the finer scale heterogeneity created by initial and delayed tree mortality in these FSCs were insufficient to create the open conditions and dense shrub cover required by species associated with shrubland and young forest. In general, increased bird abundance and species richness became evident in moderate severity burns as shrub cover and tree mortality exceeded about 30%, so that's 14% of the basal area mortality. Historically and today, 14% basal area mortality, not off. Historically and today, natural or lightning ignited wildfires were uncommon in central hardwood fires. Excuse me. Few more points. However, humans have managed forests with fire for thousands of years for multiple objectives like creating habitat for diverse bird communities. Forecasts of longer, more frequent droughts associated with climate change together with mainly human-caused ignitions will likely increase future wildfire frequency in eastern hardwood forests, highlighting the importance of understanding wildfire impacts on breeding bird and other wildlife communities. Canopy reduction by other disturbances, both natural like wind throw or silvicultural like timber harvests, elicits changes in breeding bird community composition similar to those seen after high severity wildfire. Hence, we suggest that silvicultural methods can be used in central hardwood forests to increase breeding bird abundance and richness and create habitat for shrubland bird species without adverse effects on most other bird species and without the risks and loss of timber revenue associated with high severity wildfires. Right? So wildfires will happen, but silvicultural management approaches can be used to achieve similar bird diversities and maybe manage fire in that sense as well. So just another example which I thought I'll include here as the continuing narration of biological rules and nature's rules and biological loopholes, which must be understood as we make future projections, because the uncertainty in projections is high enough and is dominated by scenarios once you cross 2050, and ecology and ecosystems and biodiversity become even more complicated because of these kinds of non-intuitive responses of ecological systems. Okay.